Hello everyone, my name is Dan the Tutor. This is a clip from one of my weekly group tutoring sessions at the University of Delaware for Math 221. If you have any questions, please leave them in the comments below. Thank you and enjoy.
Next up we have logarithmic functions, the cousin of the exponential function. Logarithmic functions. We're going to be talking about how you simplify it, the properties of logarithmic stuff. Hopefully all of this sounds familiar from the quiz last Friday. And here's what it's going to be. Let's say I have f of x is equal to the natural log of x squared times x plus 1 divided by 3x minus 4. Something like this. How would I break this up into different functions? How would I do that? Well, remember, whenever I have multiplication in a natural log, like in the numerator here, for instance, I'm going to break this up into two different integrals like so. Natural log of x squared plus the natural log of x plus 1. So remember, multiplication becomes addition for logarithms, and then we can ask ourselves, well, what will the denominator be? How do we factor that in? If you didn't know this already, hopefully you did. In the denominator, it becomes minus, so minus quantity natural log of 3x minus 4. This is mostly it. There's one more thing we can do. I see here I have x squared, natural log of x squared. Remember, whenever I have an exponent here, like x squared, then I can take this exponent, write it out in front. This is not a power rule. I'm not subtracting 1. I'm just pulling this exponent out in front, so now it's 2 natural log of whatever was left inside, which is just x in this case, plus everything else is the same. Natural log of x plus 1 minus the natural log of 3x minus 4. This is as much as it can be broken down. You may be wondering, why do we want to know this skill? Why is it helpful? I'll tell you, it is very helpful whenever you want to take the derivative of logarithmic functions, and it's going to be the basis of why we do logarithmic differentiation, which, again, we'll talk about that later. Any questions on this one? Okay, great. Next up, let's say we have y equals, this time I'm going to go in reverse order. Let's say this time I have 3 natural log of x minus natural log of x squared plus 1 plus, let's say we have 5. And I want to bring this all into one natural log. How would I do that? So here's the first thing I'm going to do. I'm going to say to myself, this 3 can be written right here as x cubed. So really this is the natural log of x cubed. Now how do I factor in the minus natural log of x squared plus 1? Remember, minus means division. So I can rewrite this now as the natural log in the numerator, x cubed, denominator, x squared plus 1. We still have this plus 5 out here. How do we deal with that? Think about it for a second. Well, if we want to get this into our natural log, the thing we're going to have to do is we need to make this, well, we need to have natural log here. So here's what I'm going to tell you to do. Maybe you know this, maybe you don't, and hopefully this won't even come up on the test. This is actually kind of difficult. But what I'm going to say is I'm going to rewrite it as this. The natural log of e to the 5th power. Notice, this is equal to 5. If you don't believe me, you can plug it in your calculator. The natural log and the e cancel out. All you're left with is 5. Why would I write it like this? Why would I bother? Because now I have natural log here, and it's addition, which means that's turning into multiplication. So in my numerator, I now have natural log of x cubed times e to the 5th. I do need to keep that e in there. Divided by x squared plus 1. This is going to be my final answer for that one. That one was kind of tricky, especially with the plus 5. But did that make sense? Any questions? Okay, great. Anyone still writing? So that's pretty much it for logarithmic functions. I don't think there's too much more to talk about. There is one more thing I want to mention, though, and that is how do we solve logarithmic functions? Kind of like how did we solve exponential functions? In other words, if I have the natural log of x equals 10, let's say, how do I solve for x? How do I solve for x? Well, to get x by itself, I need to take base e of both sides. I repeat, take base e of both sides. The e and the natural log cancel out. You get x equals e to the 10th power. And that would be how to solve it for this example. Okay? Any questions on that? Cool. So that's pretty much it for logarithmic functions.
Don't forget to like and subscribe. If you want me to start doing free weekly group sessions at your university, please post in the comments below or email me at dan@danthetutor.com. Thanks everyone. Bye-bye.